Hello and welcome back. Today we're going to be looking at arithmetic series. Okay, so an arithmetic sequence. So an arithmetic sequence is a set of numbers where each number has a constant d added to it in order to increase or decrease it. This creates a pattern where a set of numbers are increased or decreased by a common difference. So what exactly does this mean? It means that there's a pattern, or let's say a set of numbers that usually have a value added to them that increases them or decreases them. Let's just quickly look at an example and make it much easier to understand. Let's say you have 2, 4, 6, and 8. A lot of you have seen this before, most likely, and like have seen patterns like this. So now we know that they're being increased by 2 each number, sorry. Each each prior term is being increased by 2 to give you the successive term. So now this right here, this set of numbers is an arithmetic sequence, and so that's pretty much what it is, just a set of numbers increased by a common value or a constant value, I should say, rather, it would be better. And let's look at a key term here, a couple of key terms. We have a sequence. A sequence is pretty much any set of numbers separated by a comma and arranged in a specific order, usually representative of a pattern. So I mean, a sequence doesn't have to be arithmetic, it can be a different type of sequence, as we'll look at in future videos. There's geometric sequences as well. So that's pretty much what a sequence is. And then we have a common difference, which we now know is the constant value. So this value right here is the common difference. It is a value that the numbers increase or decrease by. That's all it is. Let's move on now to the formula. You know what? Let's do something different. I'll show you how we can get the formula, because this is a rather simple concept, and just from this set of numbers we can derive a formula to find any term in the sequence. So let's see. We know here that this is the first value, correct? So it is the first value. So we can give this a variable. Let's say it's a. A represents initial value. And we know that this 2 number is obviously going to be a part of something as well, so we can highlight this and give it a variable. Let's say it's d is equal to common difference or constant value. Let's get a little more room so we can work on this. And now, having these, we can derive a formula. Let's see a. Well, let's look at how we get from 2 to 4 over here. So from 2 to 4, we know that it goes from 2 to 4 if you add 2. So a plus 2 is equal to, let's say, tn2. Let's say that tn means, say that tn is equal to term value, and then the subscript is equal to the whichever term you're doing. So tn2 would mean the second term. So 4 is essentially equal to tn2, correct? And then now from here, let's see how we get from the first value. Okay, you know what? Actually, the best way to find this out would be to do a table, a term value table. I'm pretty sure you have done these before. Term value. What's that? So term number, term value. Okay. Now that we have that, let's separate that, of course. Not a clear line. Okay, so we have 1, 2, 3, 4. And then we have 2, 4, 6, and 8. Okay. So what we see here is that 2 times 2 is 4. So we know from here that t value, we can say tv is equal to 2t number. Correct? So we know that from this. However, this formula right here will not apply to every single arithmetic sequence. So we need to find a formula, a generalized formula, I should say, that will apply to all arithmetic sequences, whereas this one is specific. So what we're gonna do is we're gonna use the prior information like we were doing before, so the information that we have up here, to construct a general formula that, when simplified, will equal to this. So let's look at how we're gonna do that now. We have, so let's go from the a value to 6. It's a plus 2d, correct? Because now we have 2 being added to it twice, so we do 2d. Simple enough. So what does that give us? It gives us tn 3. Okay, so now let's see if we can derive a general formula from this. So let's go down here and write out the values that we had. So we had 2, 4, 6, 8, and we had tn2 is equal to a plus 2, and tn3 is equal to a plus 2d. Oh, you know what? Let's make this better by doing this instead, because this might confuse some of you. So actually that's not gonna work. Okay, that's what control Z is for. Alright, so we have that. Let's come down here. Alright, so a plus d, which is 2, so it's equal to 2 plus 2 is equal to 4. So from this we can see that the formula indeed works. And then we have tn3 is equal to a plus 2d, because now we're adding 2 twice, because we're jumping 2 numbers. So now we do equals 2 plus 2, just to make sure it works, is equal to 6. 2 times 2, 4, 4 plus 2, 6. So simple enough. But this still is not a general formula, because we need to have a value. If we have, actually it is a general formula, but we have to make it a little more simple still. So let's say that we have 3 here, tn3, right? That is your term number. So that is the value you're finding. The value for the term number, that is the third term number. So for the third term number, we have a. We know a is to be constant. It is always 2. We know d is going to be constant. It's always 2. But this number, the number that we're multiplying it by, is always changing. So this is the number that we need to find a clear value for. So once again, here it was 1, and now there it's 2. So this is the number that we need to find a constant for. Now how are we going to do this? Let's look at the relationship between these numbers. So here we have tn2, the second term number, and we're using 1. Here we have the third term number, and we're using 2. Now, if you still don't get it, let me do one more. So if we have tn4, it's going to equal a plus 3d, because we are adding 3 times, sorry. So now we have not a anymore, 2 plus 3 times 2, it's equal to 3 times 2, 6, plus 2, 8. So I'm sure everyone has seen the pattern by now. The number that you use here is one number less than the term number. So what this tells us is that if, for example, this was n, n, let's say, term number, so n, this would be equal to n minus 1. And now we have our formula, as we have all the constant values to find the variable. So what is the number that we're going to have? What is the formula that we have now? It is tn, so any tn, I'm not going to give it a value, is equal to a plus, once again a plus. Now instead of a number, we write n minus 1 here. N minus 1 d. And there we have it, a formula for arithmetic sequences. Pretty simple. I mean, nothing too complicated here. Like I said before. Alrighty then, let's go back now and look at our, let me just open up a new page here so that we can do an example. It's dark enough. Alright, let's go back to our PowerPoint. So, let's look at our formula, and there we have it. Tn is equal to a plus n minus 1 d. Alright, let's move on now. So question, one thing I might not have made clear might have been this. When I say n is this n over here, so it's a subscript term number. So like for example, I just want to clear this up in case any of you might have gotten confused on it. If we have if we have Tn, then n is the term number. So T2, T3. I made a mistake over here. When I wrote Tn3, it was actually incorrect because you actually write T3 because n is the term number. So you just write it like that, and then that makes it much simpler. So when you have Tn is equal to a plus n minus 1 d, you now know that this n would be the same number that was here. So if we're finding T3, we would do a plus 3 minus 1 d. So that makes sense, right? That was my fault. I made a simple mistake there. Erase all this, and let's do an example now. Make sure that we understand it. Alright, so let's take this question. Not solution, just a question. And let's work on it over here on this Word doc. Can't move the text anymore? Alright, let's move this over then. Alright, quite a short question, nothing big. Alright, so a car is traveling a set distance. The car travels 50 kilometers after the first hour, 100 kilometers after the second hour, and 150 kilometers after the third hour. How many kilometers has the car traveled after 10 hours? Now we're gonna do something unique. Now we're gonna do the same question incorrectly and correctly. So we're gonna start off with the wrong way. Okay, so let's work on this now. So we have our initial value, 50 kilometers, 100 kilometers, and after 2 hours, 150 kilometers. Okay, so this is pretty simple. Okay, so now we have our numbers and our Tn values. So let's set it up. We have 50 kilometers. Then we have 100. Then we have 150. And so what is the common difference now? Let's look. Of course, 50. 100 minus 50. Oh, to find the common difference, I should say you always do the successive term minus the prior term. So it would be, let me just tell you everything while I'm at it. 100 minus 50 is equal to 50. So, but in an arithmetic sequence, you would often do two calculations to make sure that it is an arithmetic sequence and you have the right value as well. So now we'll do 150 divided by 100. It gives us 50 again. So we know that it is 50 indeed. So I can cross this all out now because you don't need it, and just write 50 here. And 50 here. So we have our a value. A is equal to 50. It's right over here. A is equal to 50. We have our d value. D is equal to 50 as well. And we have the term value that we're finding. So we're finding T10. And if you don't get that, actually write Tn is equal to T10. And yeah, and then n is technically equal to 10. Alright, so now let's use our formula that we learned, that we derived from this. So we have Tn is equal to a plus n minus 1 d. Simple enough. Scroll down to work on it now. So our Tn, we know we're finding T10, so we can just write T10 right off the bat. And a value is 50, and n value is 10 once again, minus 1 of course, and d value is 50. Okay, so now we write equals 50 plus 9d, or sorry, not 9d, 50 plus 9, let's put the brackets around 50, and 9. Sorry about that, my handwriting got a little weird there. Alright, so I'm going to do this on the computer calculator because I know it'll work. This one, it's pretty simple calculations. Let's open it up. Calculator, and now we do 9 times 50 equal that, and then add that to our initial value, and we get 500. So what this tells us is that T10 is equal to 500, and this off with therefore the 10th value is 500. Sorry, 500. Now, on purpose, we did this question incorrectly just to show you how to do it wrong. So now let's work on it correctly and do it the right way. So here, the mistake that we made was actually this, right in the question. If we look at the question, it says the car travels 50 kilometers. Right here it says after the first hour. What that means is that the car has traveled 50 kilometers at the beginning of the second hour. Therefore, the second value, actually, T2 is equal to 50, not T1 is equal to 50. So this is wrong, and this is right. So what this means is that our initial value was 50, correct? I mean, sorry, our initial value is, we don't know, right? So but we know that the D is 50. So let's go from 150 to 100. What do? We subtract 50. From 100 to 50, we subtract 50. So let's go backwards and find our initial value for when it is a 0, beginning at the first one. So we subtract 50, and this gives us 0 as our initial value. So pretty simple, except we made a small mistake that we can now fix and use the actual initial value, which is not 50 but 0. So now with this new a value, we can calculate our new answer. I just want to make sure everyone out there got this. 50 kilometers is not the initial value, it's the second value. So 1 first value, second value, third value, fourth value, because 50 is after the first hour, not before the first hour or during the first hour. So now we can use our formula once again. Pretty simple. Let's just write it out. Let's go up a little more. I want to have a lot of room to work with right now. I'm just finish it up. So a is equal to, sorry, not a. Tn is equal to a plus n minus 1 d. T10 is the value we're finding, so a is, we know, 0, plus n we know is 10 minus 1, and d we know to be 50. So easy enough. Now we solve 0 plus 9 into 50. So from our prior calculations, actually no, I'll just do it again just to make sure. Just to make sure that everyone out there gets it as well. So 9 times 50, sorry. 9 times 50, what does that give us? What does that give us? It gives us 450. Therefore, the 10th value in the sequence is 450. So that's pretty simple. We have our we have done our example and counterexample now. So now let's take a look at another aspect of arithmetic sequences. It's slightly different, a little more complicated, but still overall pretty easy. That concept is the it seems that it okay, so let's just look at it over here then. So in order to find Tn, we did this, correct? But now we're going to do an example in order to find Tn given two terms. So we're gonna look at this question. And this formula. So we'll paste that over here. And yep, okay, so now let's take a look at this and see what it means. Okay, so let's look at this bullet for you guys. Okay, so Tn is equal to a plus n minus 1d. That is our formula for arithmetic sequence. We know this. So what we're going to look at now is a little different, but not too different. It's going to be given two terms. So we're going to copy this and paste it over here as well. So what that means is that, let's open up our writing pad over here, and let's say that we have T5 is equal to 20, for example. This is not real, it's completely fake, I'm just making these numbers up. And T9 is, let's just say, or sorry, you know what, let's say T10 is equal to 40. Okay, so now what we can derive a formula from these two values and numbers, and let's go back and look at how. Now that you understand what the question is asking for, we can look at trying to find a solution. So let's go back here and see what it says. It says that linear system is created which can easily be solved. What does that mean? It means that originally, so let's write our equation out and see what we know. So you know what, let's make up a real example just so that we can do it properly. So let's cross this out and let's write out an actual example. 1 second. Okay, so I've come up with an example now that we can actually work on. So let's say that T5 is equal to 25 and T8 is equal to 40. So let's write our equation out and see what we know from this. So let's write it out for this number right here. So T5 is equal to a plus n minus 1 d, correct? You know what, let's simplify it even more. 5 minus 1 d, correct? Okay, so now we have two variables here now. We have we have a and we have d. So what we're gonna do is oh, this is also a variable. Let's write that out. So T5 is equal to 25, right? So we can just write 25 is equal to a plus 5 minus 1, 4, and then d. So now we have two variables, and what do we do when we have two variables? We create linear systems. So if we go back to the PowerPoint, let's see what it says. Linear system is created, but it's not created yet because we have not yet solved this. So let's do it for this one as well. T8 is equal to a plus 8 minus 1 d. What does that mean? 40 is equal to a plus 7d. All right, so now we see that there's the same variables in both a and d. A and d. If we have two variables and two equations, we can isolate for one variable and solve the equation. So let's do that now. We have a here. So let's take a is equal to, let's bring this over to this side. We get 25 minus 4d. And if we do the same thing over here, we get a is equal to 40 minus 7d. So now we have a is equal to a, and what we can do from this is 25 minus 4d is equal to 40 minus 7d. Simple enough. And now we have one variable, and we can solve this quite easily. Now we will take 7 over to this side, so we'll get 7 minus 4d. We'll take 25 over to that side, we'll get 40 minus 25, and oh sorry, I forgot to write 7d. 7d minus 4d is equal to 40 minus 25. What does that give us? It gives us 3d is equal to 40 minus 25, 40 to 30, 10, 15. Now we divide by 3 on both sides, and we get D is equal to 5. Now we have our D value. Simple enough. The last thing now to do is find our A value up here. So what do we do to do that? We sub D into that, as we always do with linear systems. So if we have A is equal to 40 minus 7D, and now we have a D value, we can do A is equal to 40 minus 7 times 5, equal to 40 minus 35, which is equal to 5. So our initial value is 5. So therefore, actually we don't need a therefore statement because it wasn't a word question. It was just an example that I was doing to show you guys. Alright, so simple enough. I mean, not too complicated. Let's just do a question with it as well. Make sure you guys understand it. Alright, so let's just control Z all of this. Oh, so you can't control Z more than that. Alright, so let's just do file, new, nope. And click here. Make that. Alrighty then, let's copy down our example now and work on it. So Control C, and sorry about this, it's taking a while. Yeah, I don't know why it's not working anymore, but that's fine. Oh, it's a small question anyways. Okay, so our car has covered 450 kilometers after 9 hours and 800 kilometers after 16 hours. Find the equation for Tn. So let's find the equation for Tn now. And it's pretty simple. So like I said before, after 9 hours would mean the 10th hour, and after 800 kilometers would mean, I'm sorry, after 16 hours would mean the 17th hour. So, you know what, let's not even confuse ourselves with that. Let's just write out T9 is equal to 450 and T16 is equal to 800. Okay, so now I was wondering if any of you would see this, but if you haven't, then you weren't paying a lot of attention during the beginning of this lesson. But if you did, then good job, because it's not T9, it is T10. Just like the first example we did, the question is asking you for the kilometers after 16, which means the 17th. It's asking you for after 9, which means 10. So T10 is equal to A plus 10 minus 1D is equal to A plus 9D 450. T17 is equal to T17 equals A plus N minus 1D is equal to A plus, oh sorry, it's not right N here. 17 minus 1 D is equal to A plus 16D is equal to 800. Alright, so now let's isolate for A like we did in our other example. A is equal to 450 minus 9D, and 800. A is equal to 9D. A is equal to 800 minus 16D. So now let's use this linear system. Oh, another way to solve it, like I didn't show you this the first time, but I can show it to you. I guess I should show it to you this time, just to show you there's another way of doing it. Let's control Z all of this. The other way is You probably learned this before. It's the subtraction method, the elimination method in linear systems. You pretty much take the bigger number, or not the next sequence value, and subtract the smaller sequence value. So if you do that, you'll get, let's just write it in this way. It makes it much easier to do. 800 is equal to A plus 16D. So we'll subtract from this 450 is equal to A plus 9D. Sorry, alright, so now what we know that 800 minus 450 is going to be, use our handy dandy calculator over here. 800 minus 450 gives us 350. So let's write that down. 350 is equal to A and A, cross out, because A minus A is of course 0. And then we have 16 minus 9, or 9 doesn't look much like a 9, but 16 minus 9, which gives us 7D. Now we have an equation that we can solve really easily. 7D is equal to 350, divide by 7, divide by 7, cross, cross, 7 divided by 7 is 1, D is equal to 350 divided by 7, which we know to be 50, but if you don't believe me, let's do it over here. Oh, look at that, we already have 350. Divided by 7 is equal to 50. Like I said, just 35 divided by 7 is 0. Alright, so therefore, let's look at our question and answer it correctly. Oh, actually, we're not finished yet. What am I saying? Okay, so now that we have our D value, we bring down any one of these. Let's bring down the second one as a smaller. We have 450 is equal to A plus 9D. 450 is therefore equal to A plus 9 times 50. And so 450 is equal to A plus 9 times 5 is 45, adds a 0 as well, 450. And so if you can just cross this out right now, A is equal to 0. So our initial value is 0, our D value is 50, and therefore the equation for Tn is equal to 0 plus n minus 1 50, and 0 is 0, so I'll just leave Tn is equal to n minus 1 into 50. If you want to take it another step further, you can do Tn is equal to 50n minus, minus 50, and that is the simplest form of that equation. Another thing just popped into my head. I'm not sure if I showed you this the first time, but if any of you were wondering, I would show it to you now. I originally wrote 2, 4, 6, 8. That was my original example, right? And then I showed you that it was Tn is equal to A plus n minus 1D. And then I showed you that it was with the term value chart. I showed you that it was 2, 4, 6, 8, and it was 1, 2, 3, 4, and it was pretty much Tv is equal to 2Tn, and then I said I'll prove it. So let me just prove that now. I think I forgot to do that, and if any of you were wondering, I mean, it's pretty simple, but if you were wondering, let's just do it now like I did for the other one. So if you take 2 plus n minus 1, which was n minus 1, leave it at that, times 2. So now what we'll do is 2 plus 2n minus 2. 2 and 2 are gone, and what we have is Tn is equal to 2Tn. Tn is equal to 2n. So I know that this might be a little confusing to equate with that, but Tn is pretty much equated with n, and Tn is Tv. The reason it doesn't seem right is because this is a value term number chart. It's different from the numbers that we see here because the variables are different. I mean, here you use Tn as term number, right? However, here term number is referred to as n because you would write like T1, T2, so that's the term number, right? So I mean, sorry, that's how you write it. The term value. This is how you write term value, and just this alone is term number. So you would have n here and then tn here to show you the whole value. So that's pretty much it. So now you see that this is equated with this. It's the same formula, and you will get the right number. And yeah, I think that's pretty much it for arithmetic sequences. I know it took a while to understand, but yeah, that's all it is. It's pretty simple. All right, and thank you for watching. We'll see you back.